Hello everybody, welcome to our first tutorial in making an Apple Vision Pro application. Today we'll be creating a metronome. This metronome will teach us how to animate 3D objects. Here we have a metronome that swings it back left and right at a particular BPM. As you can see, it's very high detailed once we get closer. Here we can set a lower BPM, and we can also set a higher BPM. Now let's swing deeper into how it looks. As you can see, it's a very high quality rendering where you can see all of the characters inside the metronome. Okay, let's start by opening a project or creating a new project in Vision Pro. Let's get over here in Xcode. We'll call this a metronome 3D. We have set our initial scene to volume, and let's check that out. Here we have our initial app with a content view and an immersive view. And let's take a look at the simulator and see how it works currently. We have one toggle that enlarges our reality view content, which is our volumetric content view, and an immersive space that shows two separate items. Inside our immersive space, we can only present our own app, and we have to close all other apps. So we don't really want that, so let's remove the immersive spaces. Okay, let's get rid of the immersive spaces. Let's get rid of these options of showing immersive space and immersive space is shown. We won't be needing that. We won't be needing the open immersive space or dismissing immersive space. And we do not need this on change at all. Let's remove the entire item of on change. Let's also remove this toggle for showing the immersive space. And I think that will work for us at this point. We have our reality view, our content. We have our scene. This is our first item. On update, we're going to check out the entity.first, and if it is enlarges true, then we'll enlarge it, otherwise we will not. It will enlarge it at a uniform scale, and I don't know what that scale is, but it is a 1.4 and 1.0, and this is the gesture of tap on end of the enlarge dot toggle that would cause this particular update. I don't think we'll be needing that either. We won't be toggling very much, so let's remove that. And we won't be enlarging anything anytime soon, so we can also remove that as well. Here we have our VStack and our toggle. We really don't need any of that, so we can get rid of that as well. And currently we only have our frame and our immersive view. Let's delete that. We won't be needing that at all. Let's remove from reference. And we have our content view. Let's remove this immersive space as well. Now we have a very clean project to begin with. Let's check it out. All right, this is what we're working with. It looks like there's a frame in there. Let's remove that frame as well. Here's a frame of 360 width, some padding, and some glass background. Let's remove that. We don't really want that. And let's run it again. All right, that's very clean. Now let's replace this scene with our metronome. Okay, first we head over to Reality Kit Contents, hit Package, and hit Open in Reality Composer Pro. Okay, we're gonna grab a USDC file from our Finder and drop it in. Here we have our vintage metronome, right? And currently we have no scenes. Let's create a new scene. And let's drop the vintage in there, vintage metronome. There it is. It's quite big at this point. We can um, set the scale to be a little smaller so that we can manage it. Here it is. And we have our vintage metronome now. It has quite a couple of materials for the metronome, the wood, the trige, which is silver, and we have some markings. And we have a mesh. The resources is in the description below, and I've included the information about who made this particular 3D object. Okay, now we're gonna close this, and what's gonna happen is it's gonna ask us to save. Let's save it. It's currently under unknown, untitled scene, so let's rename that to Metronome USDA file so that we can easily find it. All right, with that, we are ready to replace that scene with the metronome. Here in content view of our metronome 3D app, let's remove this string of scene to metronome, and let's rerun the app and see what we get. And we get our metronome. As you can see here, the metronome looks kind of dark right now, so we need to add some lighting elements to light up our metronome. Okay, to do this, let's grab a skybox and throw it into our project. So here is our skybox in our Finder. It's called Studio Skybox. Let's just drop it in, hit finish. Now let's make an environment for our metronome. So let's do a let environment equals try await environment resource named studio, and we're gonna do a metronome, or let's rename this to a metronome entity, and we're going to set this metronome entity to the component of dot set the image based light component, and set the source to be dot single, and we're going to set it to our environment, which is our studio light. Then we're going to set the receiver, so metronome entity dot components dot set image receiver component, and we're going to receive it with our metronome entity. We're also going to give it some make it more realistic by giving a grounded shadow component. And we're going to set casting shadow to be true. With that, we can add this metronome entity into our scene, a reality view scene, and let's check it out. As you can see, it's much more well lit now, and let's move on. Okay, the next thing we want to do is add some controls. Let's say we have a play and pause button for our metronome. Let's introduce just the play and pause button, and afterwards, let's add the BPM selector. Okay, now we want to place this particular button closer to the user, and to do that, we're going to use a Z-stack. Right, let's put this reality view inside a Z-stack. Actually, I think we should refactor this into a separate variable. Let's call this var metronome some view, and let's just drop this in. And let's put this inside our metronome. And we're going to get a Z-stack. And we want the alignment to be a of horizontal of center and the vertical to be at the bottom. And we drop the metronome in. Let's run it to make sure it works. Perfect. Now let's add a set of controls. Let's call this var metronome controls some view. And we're going to make a VStack. The reason why I want to use a VStack is because I want a button on top and the metronome settings on the bottom. So first we're going to do the button. Here we're just going to set a task that we're going to do in the future. We're not going to do anything for now. And let's make the label. Let's label it called play. And we also want pause in the same label. We also want the system image to do play or pause. We want to run this when we have some sort of state where the metronome controls is play and pause. Let's set this to is playing. And we're going to put this into a model a little later, but currently we're just using state as a way of substituting this data quickly to get this UI running. Next, we're going to do the view model afterwards. All right, that looks good to me. And let's put the metronome controls into the Z-stack, and let's take a look at what it looks like first. And we're going to add more to it very shortly. Okay, currently it's very low on the bottom, so let's push it up. And we also don't want to have it say pause, we also want the icon to be a little bigger. So first things first, we're gonna do this for the button only. So we want the button style to be dot borderless. We want the label style to be the icon only. We want the font to be much bigger. We want, let's say 80. We want some offset of the Y at negative 250 maybe. Let's see how that goes. Okay, it looks like there's no glass background. It looks kind of funky here. Let's give it a glass background to give it some sort of like tell you that, oh, this is a control that we can that we're working with. So add a rec, corner radius, and give it 50. Here we go. And we have a little button here. It looks kind of iffy right now because we want to add maybe a metronome like selector, BPM selector, below or above. I believe below should look better. We'll try which one looks better. But right now, let's give it some sort of frame to make it wider for our viewing pleasure. So to get a sense of what we're working with shortly. So it's kind of like this. This is the play pause button. We're going to have the metronome selection down here or above, depending on how it works. And we're going to go from there. Currently, this button doesn't do anything, but we can set it to do is playing dot toggle. We set it to dot is play toggle. And here it is in the simulator. We can play and pause. Okay, let's take the next step and add a BPM selector. Here we set up the BPM that we will be updating. And next, let's add to our controls. We're going to make a VSAC with a slider and some text. Here's the slider. We're going to take in a value in and take some certain steps. So our binding is going to be BPM. Our in is going to be between 40 and 130, 40 BPM, and we're going to take steps of 1. Next, we're going to add to this by doing a control size of large, extra large, and give it some text. And that's going to be int of the metronome BPM. And that's BPM. And with that, we're going to dot font, dot title, perfect. And we're going to give this VStack a particular frame and a offset. So let's say the frame, we're going to width at 400, a height of 500, and we'll give an offset of -250 that we have up here. Now, both things are under control. Let's run it. Missing a Z label. Well, that's a Y-axis. Here we have our controls of our BPM that we can update. Here's our play and pause button. And now let's create a metronome model to hold all these variables and hold everything, the whole metronome model, in one place. This includes the playing, the player, the rate at which the timer will run, and the animations for our 3D model. All right, first hit File, New, and hit File again. We're going to create a brand new Swift file, and we're going to call it Metronome Model. Inside this model, we're going to import AVKit for audio, import Swift UI, and let's import and give it a @observable. We're going to call this class a metronome model, and let's begin. First, we're going to give it a static let default metronome BPM. I think default BPM makes more sense. Let's set that instead and set it to 90. Let's pull some of these items back into our metronome model. First things first is playing. We're going to set that in here. And we're going to take the BPM and set it in here. The BPM is going to be set to the default BPM. And let's use these variables. First, we're going to do an @environment. We're going to do a metronome model.self var metronome gnome model. Now we're going to pull this in from here. Dot environment. We're going to do a metronome model. Perfect. So with that, something's wrong. Did we spell metronome model wrong? There we go. Looks good. Okay. Here. Okay, perfect. Everything's running perfectly fine. All right, the next thing we're gonna do is remove these items here and replace it with the items in here. Okay, so by deleting these, we find out that this is no longer working. What we're gonna do here is metronome model dot is playing. Now that will work. One thing we do need to change is when it's playing, we should say pause, and we should say play when it's paused. We did this in the opposite direction earlier, and so we have to swap those. Now we have finished the is playing part. This part here is slightly more difficult because of this publisher. is bindable. So what we need to do is at bindable, and we create a model, var model equals the metronome model, and that gives us an item that we can bind. Also, this part, just use the regular model would also work, but since we have the shortcut, let's use the shortcut. Now, the next thing we need to do is return this body, because that's not a item. So now we can run this once again, but this time we're using data points from our model. Now let's start updating what happens when we click the play button in our model. So once we hit the is playing button, it should start playing some sounds. And we want it to play the sound at a certain rate. The rate that we want the sound to play is based on our BPM. So for every 60 seconds, we want to play this 90 times. So we're going to play it at 60 divided by 90. And if we want it to play 120 times, we will take 60 divided by 120. That will be every 0.5 seconds, we'll have 1 beat. So we'll have 2 beats every second. All right, so let's create that timer. Var timer is equal to timer.publish. Every time interval of 60 divided by the BPM. And on the main run loop, and .common. So every time we update our BPM did set, we're going to update our timer. Timer is going to be equal to timer.publish of the BPM. With that, we have our timer. Now let's run that timer. So on receive of the metronome model.timer, we're going to perform something, and that something is going to be make our metronome model.player.play. Now, we don't have a player yet. Let's set that up. So let player equals try AV audio player of contents of. We're going to do a bundle .main.url. So we just drop our song into our beats into our assets folder. Into our folder right here. So metronome sound and with extension .mp3. And we're going to hit that with a exclamation point. With that, we drop in our metronome sound from our metronome file here, and let's get started with the playing of the sound. So every time it's going to be set, we're going to prepare our player, prepare to play, and every time our player is playing, let's prepare to play again. This allows our player to prep for a next cycle of playing. We don't want it to play every single time. We want to only play if the metronome model is playing. Otherwise, it'll be playing indefinitely when we pause it. Now, with that, let's test. Okay. Now we should be playing our sound right now. And we should be playing our sound at this point too. But there is no sound playing. There must be some sort of issue. Alright, so the issue here was that we forgot to do the auto connect, and that's how we fixed it. As you can see here, now our simulator makes a sound at any BPM. Perfect. Now, time to animate our tridge to swing back and forth when we are playing. We should imagine that we should be able to update that here. However, our metronome entity is unavailable to us as it is locked in the reality view of this content. You would imagine that we should do an update at every single update. We would check on receive the timer that we should be playing. However, we can get around this by making a metronome entity a global entity. Now, let's make that happen. Let metronome entity equals entity. Next, we set this metronome entity to metronome, and we set our metronome entity to be equal to metronome. And with that, we should be able to run this properly. Oh, right, this has to be a var so we can update it. And with that, our metronome is functioning again. And we can get the tridge. So what does that mean? So we go to dot on receive. We're going to do the metronome model dot timer. And we're going to perform something. And that thing that we're going to do is first, if let tridge equal to metronome entity, which is dot find entity named tridge01. This is the name that we have found inside our reality kit. Let me show you. Before that, let me just close this so that everything looks fine. Right, so we go to our package, we open reality composer. All right, here it is, tridge number 1. Oh, it's a 1, not 01, so let's fix that. Otherwise, it will not find what we need to find. So 1, and if the tridge is equal, then we can update it. Tridge dot position is equal to the position that it is found in our tridge here, which are these variables here. Let's take it in meters. So that's our x. This is our y. And that is our z index. Next thing we need to do is the rotation. Tridge dot transform dot rotation is equal to dot init a rotation of angle of, let's say, this actually is in radians, so let's do 0.5, and let's set this axis to 0, 0, 1. We're changing it on the z-axis. Right, and so once we find it, we're gonna move the angle of rotation from here to 0.5, from 0 to 0.5, and from 0.5 to negative 0.5. And the way we are going to swap between the two is if tridge dot transform dot rotation is equal to this particular position, then we're going to swap to the other position. Else, we're going to go back to our original position. So with that, there is no animation at this point, but we should see some rotation. See, you can see that this is moving every single time. It moves faster with a faster beat and slower with a slower beat. Now, we want to probably add some animations to it and make sure that we have is playing before we start moving these things. Perfect. All right, it's time to produce those animations. First, let's set the start point and end point of those animations. So static let trij of left point is going to be a sim quid of a f, which is a float, at the angle of negative 0.5. We can look this up at the dot init from earlier, 0, 0, 1. Now we're going to do the right side and the position as well, because we'll be needing that. Here's the right, 0.5. The position is going to be a tris position. Is going to be a sim d3 of a float type, and we're going to set it to be equal to our position that we set earlier here. Now, with that, we have that done for us. And, oh, right, is there an issue here? Yes, we have to do that. Okay, a colon there. And now let's make some computed properties of swinging right. Var swing right from two animations of dot transform type. And we're gonna set this to a from to animation with a particular name and everything. I'm gonna call it swing right. We're gonna do a from. We're gonna do dot init. And we're gonna do dot init again. Rotation. So rotation is gonna be trij left. Well, the metronome model. Trij left. And we have to have a transition. Translation of type position, because this animation updates both the position and the rotation. So with that, we're going to do a 2. Same deal, but we're going to the left side, to the right side. And we're going to do a duration of 53 divided by the BPM, because it needs to be faster than our timer, the sound, because we can't wait for the sound transform. And with that, we should be done here. Transform. Perfect. This should be our swing right. We need to animate this. Swing right with our animation resource. And that's going to be try animation resource dot generate with the swing right from to animation. Now we're going to do this for the left side as well. Swing left. That means we have to swap trij left to right and trij right to left. Very easy. And this left is going to be, this right is going to be left, and this is going to be left as well. And with that, let's start those animations and make it run. So here we are. We need to make sure that it's playing, and then if it is playing, we can, based on this rotation, we can set it to go a particular way. And once we set that rotation, tij.play animation, and we're going to set this animation resource to metronome model dot. We're going to swing, since we're going to the left, we're going to swing left because it's negative, and positive is swinging right. And with that, we have our animation set, and this should run perfectly. All right, hit the BPM button, and we are on board. Now let's slow it down, and let's speed it up. And with that, we are complete with our metronome. And I hope you enjoyed this video. This app is available on the App Store, and you can also find the GitHub page to work on the project yourself. There is also a website linked below for your viewing, and more of my apps are linked in the description below. Thank you very much. I'll see you in the next one.